we are going to proceed with the second subtopic, which is the Magnel diagram construction. So equations 5 to 8 can be used to determine the range possible prestress force values for a given or assumed eccentricity, right? So this is what we have done previously in example 2, right? Okay, whereas we have already been given the value of the eccentricity, okay, and we are able to calculate four values of the prestress values, okay, and based on the prestress values, okay, we are able to determine what are the values of the minimum, what is the minimum prestress value, and also what is the maximum prestress value. However, okay, different assumed eccentricity values requires tedious and repetitive calculations, right? So if we have different value of eccentricity, therefore we are going to have to calculate for 4 times, okay, using these equations, okay, in order to get the range of possible prestress values. And there is also a possibility of assuming eccentricity values that results in no overlaps of prestress values, right? So it means that we are not going to get the minimum and also a maximum value, right? So therefore, okay, we have this Magnel diagram, okay, which is a graphical method, okay, with a more practical approach, right? So we are going to look into the development of this Magnel diagram. Right. So as for the equations for the Magnel diagram, right, so we are actually going to use the similar equations, okay, that we have already used previously, right? So as you can see here, we have equations 5 to 8, right, which are the equations that we have used to determine the values of P naught, right? Okay, and we are going to develop, okay, the equations for the Magnel diagram, okay, which are from these equations actually, right? So you can see here that we have equations 17 to 20, right? So from 17 to 20, these are the equations, okay, in which is also using these values, okay, or these equations. So these equations has been rearranged, okay, in order to get these equations of 1 over P naught, right? So we have 1 over P naught, okay, for two equations at transfer and also two equations at service. So these are the four equations that we are going to use in the construction of the Magnel diagram, right? So as you can see here, okay, based on these equations, we can see the linear relationship, okay, between 1 over P naught, okay, with E, right? So this E is the eccentricity, right? So the graph that we are going to develop, okay, will be of 1 over P naught, okay, versus E, right? So we can see here, these are the example of Magnel diagram construction, right? So we have a graph, okay, with 1 over P naught as the y-axis, and also we have E, okay, which is the eccentricity as the x-axis, right? So based on the equations of 17 until 20, right? So we can see that we can actually plot, okay, the a graph, okay, and also shade, okay, the area that we are going to fulfill based on the inequality equation, right? So you, as you can see here, if we go back to the previous slide, right, so you can see here from the equation, okay, we have this inequality equation, right? So based on these inequalities, okay, we can actually shade the lines, okay, whereas we can determine the boundary, okay, that fulfills, okay, our inequalities, right? So you can see here, so this is the graph, right? So this is one example, okay, whereas we can plot, okay, the first line, okay, which is a linear line, okay, for from equation 17, and you can see here this is the shading, okay, whereas we can see if we go back to the equation, right? So as for this one, okay, we know that 1 over P naught is less or equal to this equation. So this is for equation 17. So we can actually shade the area, right? So this is the acceptable area for equation 17. Okay, then for equation 18, right? So we can plot another line, right? So we have equation 18, so this is the shading, right? Then we have equation 19, right? Then we also have equation 20, right? And based on this, okay, what we can actually determine, Okay, okay, so we go first to the E maximum, right? So this is for the maximum value of eccentricity, right? So we also have this maximum value of eccentricity that will be determined earlier, right? So that would be our boundary or the maximum value. Okay, so here, okay, based on the values, okay, that we have already plotted, right? So we have plot the lines, okay, and also we have shade the boundaries, right? And also we have this E maximum. What we can actually determine here is the permissible pre-stress value, right? So this is the area, okay, whereas we are going to determine the values based on these boundaries, okay, right? The next one, okay, is this one. Okay, so this is another example. Okay, and we can see here, so this is the permissible area, right? So as for this one, the permissible area is supposed to be here only, right? Okay, whereas we are going to consider only this area, okay, because we have this 18 line here, right? So it cuts the permissible area to be of this value, right? So my mistake here, okay, I mistakenly provide the values that is much larger than the permissible area. Okay, right? So this is for the E maximum, okay, which is this value here and also here, right? So this E maximum is actually the value of maximum eccentricity, okay, that allows for the overall depth of section, okay, cover to the pre-stressing tendon, and also provision of shear links and etc. Right? So this value can actually be calculated, right? So we are going to consider these factors. Okay, right. So a Magnel diagram, okay, is a powerful tool that covers possible solutions of the inequality equations. So it enables a range of pre-stress force and eccentricity values to be investigated. So values of minimum and maximum pre-stress force can be read from the diagram together with its corresponding possible eccentricities. So the minimum pre-stress force can be determined, okay, based on the largest value of 1 over P naught that corresponds to the maximum eccentricity. So if the eccentricity is reduced, the pre-stress must be increased to compensate. Right? Okay, so these are just the description, okay, on the Magnel diagram. Okay, so what are the values that we can actually determine, right? Okay, so now we go through the example, right? So when we go through the example, then it would be much easier for you to understand, okay, with regards to this Magnel diagram construction. Okay, so what you have to do, okay, is that for this question, it requires us to construct a Magnel diagram, okay, for the beam given in example 1, right? So still we are proceeding with the first example, okay, right? So determine the minimum and maximum possible values of pre-stress forces, assuming a maximum possible eccentricity of 130 mm, allowing for cover and etc. to the tendons, right? So this is the maximum possible eccentricity, okay, that we are going to use for our question, right? So this maximum possible eccentricity can actually be calculated, okay, by having half of it's not half, it's the distance from the centroid, okay, of our section, okay, to the bottom part, okay, or to the center of our tendons, right? So then from there, okay, we will be able to calculate the possible maximum eccentricity. So later I will show you how to calculate this, right? Okay, so here, okay, we have similar values of limits, okay, stress limits at transfer and also at service, okay, that we have used previously. Then we also have K, then we have ZB and also ZT, right? Then we also have A, which is the area, as well as moment minimum and also moment maximum. Okay, right, so this is for the solution, right? So these are the equations, okay, that we are going to use for the construction of the Magnel diagram, right? Okay, so we can see here, okay, what we are going to do based on the values that we have from the question, we are going to just substitute the values into this equation, right? So you can see here that we have 1 over A, so we have the area. Then as for the eccentricity, we are going to leave this as the unknown value, right? So we are going to have 1 over P naught, okay, and also we are going to have the E value, right? So we have a linear relation, okay, between these two values, right? So we have A, then we have ZT, we have F prime minimum, and also M minimum, and also ZT, right? So what we are going to do is just that we are going to substitute the values into this equation. But as you can see here, okay, so there are a few unit conversions that we have to undergo, right? Okay, so as for this, okay, we are going to look through, okay, for the unit conversion, right? So here, okay, so this is one example, okay, which is from equation 17, right? Okay, so these are the units that we are using here, okay, which are millimeter square, okay, for the area. Okay, then we have millimeters, okay, which is for the eccentricity. Okay, then we have millimeter to the power of 3, okay, millimeter cube for ZT. F prime minimum is Newton per millimeter square, right? Then M minimum, we need to convert the value, okay, from kilonewton meter, okay, to convert the unit, sorry, okay, from kilonewton meter to Newton millimeter. Okay, then as for ZT, also it is in millimeter cube, right? Okay, and since we know that for the P naught value, it is actually of the unit of kilonewton, right? So therefore, here we have to multiply with 10 to the power of negative 3, right? So therefore, in the equation, we are going to multiply all this, okay, with 10 to the power of 3, okay, in order to compensate, okay, with this P naught unit, right? Then we are going to in order to ease the calculation and also for the graph plot, right? So since if we are just using these units, right, so the value that we are going to have will be of a very small value. So therefore, to ease calculation and also for the graph plot, okay, what we are going to do is that we are going to multiply the whole equation with 10 to the power of 6, and to avoid any effect to the equation, okay, so therefore we are going to multiply this part, okay, which is on our left, also with 10 to the power of 6, right? So therefore the equation that we'll get here is will be 10 to the power of 6 divided by P naught, which is equal to this equation multiply with 10 to the power of 3 and also 10 to the power of 6, right? Okay, so if we go back, okay, so you can see here, right? So in this equation, right, so we can see that we have 10 to the power of 6, okay, divided by P naught, okay, and also you can see here that we have these equations, right? So these are the values, okay, from the previous equations, right? So we have equation 17, 18, 19, and also 20, right? So if we go back to the previous slide, right, so for equation 17, right, so we can see here, okay, that for equation 17, when we substitute all the values, okay, and we can see here that we have the value of the denominator, okay, becomes a negative value. Right, so there is a mistake here, okay, whereas this value is supposed to be negative 1. Okay, it is not 0, but the value is negative 1. Right, so when we add up this value, right, so we can see that the denominator sign is negative, right? So if we still remember, when we go through the equations to determine the pre-stress force values, okay, so we have the changes in the sense of inequality, okay, for the equation if we have a negative value of denominator. So similarly goes here, okay, whereas when we have this denominator to be negative, so therefore instead of having this inequality sign of equal or less than, right, so therefore, okay, we are going to change the sense of inequality to be larger than or equal, right? So this will be the new equation, right? So when we rearrange the equation for equation 17, right, so we can see that we have 10 to the power of 6 divided by P naught is larger or equal to negative 224 plus with 38.5 E, right? So this is for equation 17, right? Okay. So next we move on to the equations, right? So these are the equations, right? So these are the equations, right? So we have four equations, which are the inequality equations for the Magnel diagram construction. Okay, right. So what we are going to do first, okay, is that we are going to determine the points for the Magnel diagram, right? So to do that, okay, we are going to have to plot, okay, or to calculate a few values, okay, that is from the that is for the Magnel diagram, right? So these values can actually be calculated, okay, based on these linear equations, right? So we have E, and also we have this 10 over 6 P naught, right? So what we are going to do here, okay, is that we are going to calculate using some values of eccentricity. Right, so as for this example, since we are dealing with a rectangular section, so therefore the centroid sits right in the middle of our section, right? So if you still remember on the sign conventions, okay, for a pre-stressed concrete design, right? So the bottom part, okay, of bottom the to the bottom of the centroid, okay, we are going to consider the eccentricity to be positive, but to the top of the centroid, okay, the value of the eccentricity will be negative, right? So we can see here that we are going to select a few values, okay, that is to consider, okay, the equations from 17 to 17 to 20, sorry, right? So we have these equations, okay, and we are going to substitute the values of eccentricity, right? So as for this example, okay, we are going to use 60 and also 120, right? Considering, okay, that under this centroid here, okay, we have half of the height of this beam. So half of this height of this beam is 350 divided by 2, okay, which is 175, right? So we are going to take like a few points, okay, that is under the centroid, and also one point at which is on top of the centroid, right? So as for this example, we are going to take the range of 60 and also 120, right? So based on this, okay, based on this eccentricity that is substituted into this equation, right? So these are the values, right? So actually these values, we can go for a minimum of 3 points, okay, because these equations are linear equations, right? So once you have the at least 2 points, okay, then you will be able to plot the graph, right? However, okay, you should select, okay, the most suitable scale that is for your graph. Okay, so next, okay, we go to our graph, right? So these are the values that we have determined earlier, okay, based on the eccentricity, right? So this is the graph paper, right? So we can draw this scale, okay, on your graph paper, right? So this is for the E value, right? Then we have this for 10 to the power of 6 of P naught, okay, over P naught. So this is for the vertical axis. So for the horizontal axis, we have E value, right? So for the scale, right, so the scale can be different, okay, between the horizontal axis and also the vertical axis, right? So you can see here we have the intervals of 20, but as for 10 to the power of 6 over P naught, okay, the range here, okay, or the interval here is 500. Okay, so then, okay, we are going to plot the linear lines, okay, one by one. So the first one is for equation 17, right? So as for equation 17, right, so we have this linear line, okay, and we know that as for equation 17, okay, the equation gives us an inequality sign of larger than or equal, right? So therefore you can see that we have shaded the area, okay, that is on top of the linear line. So next one is for equation 18. So similarly for equation 18, right, so the inequality sign is larger than or equal to, right? So that is for equation 18. Then the next one is equation 19, right? And also equation 20, right? So only for equation 20, okay, we have the inequality sign of less than or equal to. right? So when it is less than, okay, then you can see that the shaded area, okay, is below the line, right? So this is the one. So therefore, okay, based on that line, okay, we can actually determine the permissible pre-stress force area, okay, which is colored here in yellow, right? So if we go back, right, so we can see here that we have these boundaries, right? So we have equation 19, right? So this is the boundary. Then we have equation 17, so the boundary becomes here, right? So then we have equation 20, right? So here is the boundary, and also we have equation 18, right, which gives us the boundary here, right? So based on this, okay, we can actually plot, okay, the permissible area, right? So this is the permissible area, okay, that is allowable for our section, right? So then based on this, okay, we will be able to determine the highest value, okay, within the permissible zone, okay, and also the lowest value, right? So this is the highest value, which actually will give us the minimum P naught, and also we have the lowest value here that will give us the maximum P naught value, right? So based on this, okay, also, okay, we have another line that can be plotted, okay, which is the E maximum, right? So here in the question, we have been given the value of E maximum of 130 mm, right? So this is the boundary, okay, and as we can see here, the permissible zone, okay, is not touching the E maximum, right? So therefore it is acceptable. However, if this E maximum is to the front, right, so therefore we have to consider this as well, okay, right? So then we have minimum P naught, right, which is from the highest value, and also we have maximum P naught, which is from the lowest point, right? Okay, and based on that also, okay, based on this graph also, okay, we will be able, okay, to determine the value of the eccentricity, right? So this is the highest value, and this is the eccentricity value, which corresponds, okay, to the highest value of 10 to the power of 6 over P naught, right? So this is E over 124. Then that is the highest value, okay, whereas it is read as 2450. Okay, then we have the lowest value here, okay, with the eccentricity of 16, okay, with the lowest value of 10 to the power of 6 over P naught, okay, of 850. Right, so these are the values that we are going to use to calculate the value of P naught, right? So the highest value is 2450, and the lowest value is 850, right? Okay, so this is the graph. And also, okay, based on this value, right, or based on this graph, okay, we will also be able to determine the maximum economic pre-stress force, right? So this maximum economic pre-stress force, we have already learned how to calculate earlier, okay, in example 2, right? So here, as for the construction of the Magnel diagram, okay, this value can actually be determined directly, okay, that is from this graph, right? So how is it is determined, okay, is by having the intersection, okay, between equations 20, okay, and also equation 19, right? Okay, so you can see here that we have these two the intersection, okay, between these two lines, right? So we have point A, right? So this value actually is almost similar, okay, to what we have already calculated in example 2, right? So the value that we have here is 1000 and also 1050 kilo Newton, right? So from the Magnel diagram, okay, we can actually determine the value directly, okay, right? So let's go back to the highest value and also lowest value that we have already determined earlier, okay, from the Magnel diagram, right? So from this value, okay, we will be able to calculate the minimum pre-stress force and also the maximum pre-stress force. So the highest point here is 2,450, right? So we are going to substitute this value into this equation, right? So we are going to not substitute, right? So we are actually solving this equation, right? So therefore this P naught, okay, will be 408 kilo Newton, which is corresponding eccentricity of 124 millimeters. Then as for the lowest point, right, so we have the value of 850. So what we did, okay, is that we solved this equation, right? So therefore we are going to get the maximum pre-stress force of 1,176 kilo Newton, which with its corresponding eccentricity, okay, of 16 millimeters, right? So we can see here directly, okay, from the Magnel diagram, okay, we are able to determine the minimum pre-stress force and as well as the maximum pre-stress force. And if we are referring to other values as well, okay, within the permissible zone, okay, we will be able to determine the value of the pre-stress force as well, right? So for example, if we are going for like the eccentricity of 80, right? So therefore here from this point we will be able to determine what is the value of the P naught, right? Which is within the permissible zone, right? So as you can see from the Magnel diagram, okay, we are actually given the range, okay, of values, okay, for the pre-stress force as well as for the eccentricity. So a variety or a various eccentricity and also a pre-stress force can be used for our section as long as it is within the permissible zone, right? Therefore it already fulfills all the inequality requirements. Okay, right. So this is the maximum economic pre-stress force that I've mentioned just now, right? So as for the value that is from the Magnel diagram, okay, the value is 1,053 kilonewton, which is slightly different based on what we have calculated using the equation. Okay, right? So the Magnel diagram can be used to investigate possible solutions for the design of pre-stressing force and also eccentricity. So for a fixed value of pre-stress force, the corresponding range of permissible eccentricity can be read directly from the diagram. So alternatively, if the eccentricity is fixed, the diagram can be used to investigate the range of possible pre-stress force, right? So that is the advantage of having this Magnel diagram. Okay, so this is what I want you guys to do, right? Which is a reflection exercise, right? So based on the example that I have shown you, so what I want you to do is for you to copy back the solution of example 4, okay, on paper using your own handwriting, right? So I want you to write back, okay, the example. Just refer to my notes and also refer to my calculation. Only that I want you to recalculate back whatever that has been calculated and make sure all calculations are shown step by step, right? So this will require you, okay, to write back all the equations, okay, by substituting all the values into the equations 17 until 20, right? So if you still remember in equations in the example, right, so what I did, okay, is that I've given you the equations, but the equations does not have a complete calculation, right? Which are these equations, right? So I have already calculated this, okay, and I'm only giving you the values, right? So these are the values, these are the equations, okay. So I just shown you, okay, only this equation or only this calculation, right? So this is one example which is a complete calculation for equation 17. So what I want you to do is that for other equations as well, 18, 19 and also 20, you need to substitute the values and also recalculate the values. Okay. Right, so that is for the reflection exercise, right? So I want you to have the value step by step. Okay, and next is that you have to redraw the Magnel diagram on a given graph paper, right? So I'm going to give you through Microsoft Teams and also through through Telegram, right? So I'm going to give you a graph paper in case you don't have one, right? So what you have to do is that you have to redraw the Magnel diagram, okay, on the graph on the given graph paper, right? So recalculate all the equations, okay, and redraw the Magnel diagram. Then next is to try to determine the maximum and minimum pre-stress force values and its corresponding eccentricity from your own graph, right? So please remember that your value and my value might be slightly different, right? Okay, because it actually depends on how precise we can actually draw the value, the graph, right? So then what you have to do, okay, from your work, okay, is that you have to take picture, okay, or scan your work, then convert it to PDF, okay, and submit via Microsoft Teams by this week, right? So I'm going to show you later, okay, through Microsoft Teams, okay, on how to upload your work. Okay, so then another one, okay, so I'm giving you another example, okay, or not another example, another exercise, okay, whereas you can do this yourself. Okay, so this is a passive question, okay, for Magnel diagram, okay, whereas you can use this as your self-assessment, right? So you can use this to check your understanding, okay, and try to answer the question, okay, which is for Magnel diagram. Okay, so question E is for Magnel diagram, and as for question B, it is considering the practical pre-stress force, right? So this can also be determined, okay, based on the Magnel diagram. Okay, right? So I think that would be all for our lesson this week, okay, because this Magnel diagram is quite a challenging thing to do, right? So it is quite challenging for you to understand, right? So take your time, okay, to understand this, and in case you have any questions, feel free to contact me, okay, via any means, right? So you can use Teams or you can use WhatsApp and so on, right? Okay, so till then, thank you very much. Assalamualaikum.